When we looked at the elastic properties of solid materials, we saw that a material can deform under an applied stress. We saw that a stress could be applied both perpendicular or parallel to a surface. So what happens if we apply a stress to a fluid? Well, if a shear stress is applied, the fluid will flow. But unlike a solid, it will continue to flow rather than reaching some maximum deformation. So when you look at a stationary fluid, the only stresses present will be perpendicular to the surface. We call this stress the pressure. Now, fluids have their own internal pressure, which arises due to the motion of its atoms and molecules. Collisions constantly occur between particles, and so tiny forces act in all directions. Imagine placing a small object inside this fluid. Although each collision exerts just a tiny force, the total force over the entire area of the left side points on average perpendicular to the surface to the right. Now, the pressure exerted by a fluid is the force per unit area. The SI units are newtons per square meter, which we call a Pascal. However, there are many different pressure units that are often used depending on the application. For example, meteorologists measure pressure in millimeters of mercury. This unit is based on measuring changes in atmospheric pressure by measuring height changes in a column of mercury. The standard pressure of our atmosphere is 760 millimeters of mercury, which is equivalent to 101.3 kilopascals. Because atmospheric pressure is such a standard to compare other pressures against, we also have units of atmospheres. Naturally, this pressure scale is set so that 1 atmosphere is equal to 101.3 kilopascals. Now, here are 2 important points to keep in mind. Firstly, at any point in a fluid, the pressure will be the same in all directions. After all, if the pressure wasn't the same, say on either side of this purple square, it would experience an unbalanced force and begin to move. In this unit, when we look at the pressure in a fluid, we are going to consider the fluid to be at rest. Secondly, although the pressure at any one point is the same in all directions, the pressure can vary from point to point within the fluid. Take a look at the next video to see exactly how pressure depends on the location within a liquid.